Hello everyone and welcome back to my channel. Have you ever wanted an AI that can understand pictures, videos and code just as well as it understands your words? Well, Google DeepMind has unleashed their incredible Gemini family of AI models. Get ready to dive in today. I'm going to show you how to harness their power with the Gemini Pro and Pro Vision model. So, let us get started. Welcome back again. Gemini is a family of highly capable and multimodal models developed by Google DeepMind. But first, what is a multimodal? A multimodal is an AI model that can process and understand information from different sources, such as audio, video, or text. Gemini was trained on a massive dataset of text, audio, video, images, and code to create a model with broad capability and exceptional performance. Google DeepMind optimized Gemini for three different sizes: Gemini Ultra, Gemini Pro, and Gemini Nano. Gemini Ultra is the largest and most capable model for highly complex tasks. Gemini Pro is the best model for high performance and scalability. And Gemini Nano is the most efficient for on-device development. Tonight, we are going to see how we can integrate with Gemini Pro and Pro Vision model. So, let's start coding. Alright everyone, let us start writing the code to build our first application with the Google Gemini family. The first step is to go to aistudio.google.com and then create an API key. After that, copy the API key and save it to a local file in your machine and create a variable Google API key and paste your Google API key here. This API key, we are going to use it for authentication to Gemini. And this way we are going to load it from the environment variable. Okay, so the first application that we are going to create is a simple application that will demonstrate how we can integrate Google Gemini family with LangChain. This application will allow us to chat with Gemini Pro using LangChain Google Gen AI. Alright, let us now start integrating LangChain with Gemini family. We have a library called LangChain-Google-Gen AI. This library gives us access to Gemini and Gemini Vision models and other generative models. So let us first install this library by running the following command. So we'll say pip install LangChain-Google-Gen AI. It's installing. Let us now check the version. We have pip show LangChain-Google-Gen AI. We are using version 0.0.9. After that, let us now install Google Generative AI using the following command. So we'll have pip install Google-Generative AI. This library will let us use Google's powerful generative model directly with LangChain. Google integrates Gemini into all of its products such as Document, Sheets, Drive Photo, and more. We will start seeing Gemini's capabilities throughout Google's offering. This integration will likely inspire the need for many other supporting applications. So we will use Google-Generative AI when we start working with Gemini. The next step now is to set up the authentication to Gemini. So let us load the Google API key from the environment variable. So we'll say here environment variables. So we'll say from dot environment import load underscore dot environment and find underscore dot and then we'll say load underscore environment override equal true. Let's run the code, and it loads the Google API key. To test if the authentication was successful, we can run the following command to list the available model in generative AI. So let's say here authentication, say import Google generative AI as Gen AI. Say for model in Gen AI dot list models print model dot name. Let's run the code, and we can see the list of available models. Now let us start integrating Gemini with LangChain. So here, let's have integrating Gemini with LangChain. Now let us start build our application, which is going to be an app that allows us to chat with Gemini Pro using LangChain Google Gen AI. Alright, so we'll go to LangChain underscore Google underscore Gen AI and then import chat Google generative AI. Yeah, correct. Then we'll create our large language model object. We'll say LLM is equal to chat Google generative AI. The model name is the Gemini Pro, and we'll set the temperature to 0.9 for creativity. As I said in the introduction, Gemini Pro is the best model for high performance and scalability. Okay, next let us invoke our large language model and pass a question which will be our prompt. So we'll say response is equal to LLM.invoke. I have already prepared a question, so let's say write a paragraph about how will cats control the words in 100. Okay, the answer to this question will be stored in the response content. So now if we say print response dot content, we should get our answer. It's running. Let's wait for a second for it to finish, and we get the result. All right, this is just a simple application to show you how we can integrate Gemini family with LangChain with just few lines of code. All right, everyone. In this part, we are going to demonstrate how to use prompt template and chain with Chat Google Generative AI and Gemini Pro model. All right. So first, we'll go to LangChain.prompts, and then we are going to import prompt template. After that, we are going to LangChain.chains and import LLM chain. Now we are going to create our large language model object. So say LLM is equal to chat Google generative AI. We are using the constructor of chat Google generative AI, and we are passing model as Gemini Pro. Now let us create our prompt. So we'll say prompt is equal to prompt template dot from underscore template, and here we are going to write our prompt template. I have already prepared a prompt template. So we are saying here you are a tech influencer, draft a LinkedIn post comparing topic. The placeholder here is the variable part of the prompt, and it will let us easily swap different topic. capability to another popular NLP library like Spacey or LTK. Keep it concise and highlight key differences. Next step, we will create the chain. So we'll say chain is equal to LLM chain. We are calling the constructor of the large language model chain for LLM. It is equal to LLM, the object that we created, and for prompt is equal to the prompt that we just created, and verbose is equal to true to show the log. Okay. For testing purposes, let's define a topic here is equal to LangChain. Next step is to invoke the chain. So we'll say in chain.invoke, and we'll say the input is equal to topic. Okay. This will return a response, so we'll store it in a response object is equal to chain.invoke. After that, we will print the response. So print the response. Now we will run the code. As we can see here, the log, we have entering new LLM chain. And we get the answer. As we can see here, the response is a dictionary with two keys, topic and text. So if we want to see the topic, we'll say print response topic, and if we want to see the text, we will, which is the answer that we are looking for, we'll say response text, run the code, and we get it. And that's how we can create a prompt template and chain. In this part, we are going to demonstrate how we can create a system message and a human message. Okay. Unfortunately, Gemini Pro does not have a dedicated system message structure like the OpenAI chat completion API, but it can be embedded in the human message. The reason for that is Gemini Pro might be geared towards fluid conversational generation, and system messages would inform a strict structure. But luckily, LangChain design allows the flexibility to embed instruction within the prompt, which will give us more control. But keep in mind that Gemini team might introduce system message functionality in the future. Okay? And what do I mean by system message? System message is a directive we provide to establish the AI assistant tone, personality, or instruction. It is a powerful tool to guide the model behavior within the conversation. Okay, so let us now start writing the code. We'll say from LangChain _core .messages import human message and system message, and then we will create our LLM object chat Google Generative AI. We are calling the constructor, and the model name is equal to Gemini Pro, and we are going to introduce a new variable here called convert system message to human, and we are going to set it to true. This variable converts system message to human. We set it to true because we want the behavior of using a system message. Next, we are going to invoke the large language model, and in order to invoke the large language model, we have to pass a list of arguments. So let's say here we have output is equal to LLM.invoke. Alright, and we are going to pass a list of arguments. The first one is the system message, and the content is equal to let us play a yes or no game. So we want the model to answer by either yes or no only. That's it. And then the human message is equal and content equal. We are going to pass the question, can a cat fly? And next, let us print the output content. If we run the code now, we should get a yes or no answer. and I get an error. That's because here I forgot to put a comma. It's running and we get a no answer. And if you want to check, let's say, can a bird fly? And that's how we can create a system prompt for Gemini Pro model. In this section, we are going to see how we can stream the large language model response. But first, what is streaming? Streaming refers to delivering the response in a continuous stream of data instead of sending the entire response simultaneously, similar to ChatGPT. This will allow the user to receive the response piece by piece as it is generated, which can improve the user experience and reduce latency. So here let us create an LLM object and see how we can stream the response. So we'll say LLM is equal to chat Google, generative AI, model is equal Gemini Pro, and temperature is equal to 0.9 because we want some creativity in this example. And prompt is equal, I have already prepared a prompt, I'm just going to copy and paste it. Alright. Imagine the law of physics were completely different in an alternate universe. Describes this universe with a focus on three aspects: how gravity works, the behavior of light, and the impact on everyday. Now we are going to stream the response. So we'll say for chunk in LLM.stream prompt. We'll say print chunk.content. And in order to see each chunks alone, let us here say print hash times 100 after every chunks. Now we will run the code. And we can see how the response is being streamed instead of waiting to get the full answer once, chunk by chunk. And this is how the model sends pieces of the response as it completes them rather than waiting until the entire response is finished. And that's how we can stream the large language model response. Alright, we reach now the final part. So in this part, we will see how we can use LangChain and Gemini Pro Vision to generate text from images. As I said in the introduction, Gemini Pro Vision excels at understanding images. Think of it like your image analysis expert. It can give you detailed description, create summaries, and even answer tricky questions about what it sees. We can feed it images by different ways, such as URL, file path for a local file, base64 encoded image, or by using the Python image library. Python image library is a free library that lets us do all sorts of cool stuff with images in Python. To install it, run the following command. We'll say pip install, scroll below. Now let's import the image class from the pill library and import our image. So we'll say from pill import image, and then we'll create a variable called image, which is equal to image.open image.jpg. I already have an image called image.jpg in the same folder as this Jupyter notebook. Okay. Now, if we want to check what is this image, we'll say image. Let's run the code. And this is the image that I have stored. So again, here we imported the image class library from the pill library, which is the Python image library. And the image.jpg is located in the same directory as this notebook. Okay. And here's the image. Okay, now let us combine everything we learned so far. We want to create an application that will analyze this image, and we want to ask it, what does it see? What does this image contain? And how does she identify the object in this picture? Okay. So we'll say from LangChain underscore core dot messages, import a human message, and then from LangChain underscore Google underscore Gen AI import chat Google Generative AI. Okay, then we'll create our object. We'll have large LLM is equal to chat Google Generative AI, and for model here I'm going to use the Gemini Pro Vision. For the prompt, we want to ask the large language model to analyze the image, identify the object in this image, and tell us what are the object and how did it find it. Okay, so we'll say prompt is equal, what is this picture about? How can I identify the object in this picture? Next, we will define a human message with a keyword argument called content. So we'll say here we are calling the constructor and the keyword is content. This content will contain a list of dictionary. Each dictionary contains either a text value or an image value of type image URL. So for the first dictionary, we'll have type is equal to text, and the text is equal to prompt. The value of the text here is the user prompt. Now for the second dictionary, it is going to be of type image underscore URL, and the value of the image underscore URL is the image object that we defined here, which is this one. So we want the LLM object to analyze this picture, identify the object, tell us what are these objects are and how we can identify them. The value of this image URL can be a public image URL, a local file path, a base64 image, or a Python image library, as I said at the beginning. Okay. Finally, let us invoke the LLM. So we'll say here response is equal to LLM.invoke. And then here we are going to pass a list containing the message object as an argument. And let's print the response content. So we'll say print response.content. Let's run the code. I get an error here. Yeah, I think I have a spelling mistake. Yeah, here chat. And we get the response. This is a picture of a group of cats sitting outside. It was able to identify the object, and you can identify them as cat by their shape, size, and fur. Now for the final example, we will import an image from a URL, and then we are going to ask the same question here. We are going to ask the LLM object to what is this picture about and how can I identify the object in this picture. But first, let's see how we can import an image from a URL. Okay, so first we have to import the request library, and then from IPython.display import image. For image underscore URL is equal. I have already prepared an image. This is the URL. Then we'll say content is equal to request. We are making an HTTP request to this URL to get its content. Image underscore URL dot content. We'll say image underscore data is equal to image class, and we are passing the content. Now if we want to display the image, let's run the code. Yeah, and this is a picture of a beautiful cat. Okay, now if we copy this image URL and paste it here and run the code again, and we get the response. This is a picture of a cat. You can identify it by its green eyes, black nose, white paws, gray and white fur. And this is how you can build an application to chat with your picture or any picture, to analyze pictures that you have. And as we can see, the Gemini Pro Vision is very powerful model. Okay? By this, we reach the end of this tutorial, and this is just an introduction to the Gemini family. In the future, I'm going to create a more advanced tutorial about how to create advanced application. Okay? Alright, by this we reach the end of this tutorial, and we saw how we can integrate LangChain and Google Gemini's family and create a wonderful AI application. I hope you learned something new and you increase your knowledge. If you enjoyed this video, please don't forget to share, like and subscribe. And one final note is that I'm going to create a more advanced tutorial about how you can create advanced AI application with Google Gemini's family. Okay? See you in the next tutorial and happy coding.